Okay, so in this lesson, we're going to continue our study on solving radical equations, and these radical equations will end up being square root equations. Now, these square root equations that we're going to solve will lead to quadratic equations. So in a previous lesson, when you solved quadratic equations, they led to linear equations. Now you can look at situations where they're going to lead to quadratic equations. Just remember this, when you raise both sides of an equation to an even power, you must check for extraneous roots. So in all of these problems, you're going to notice that it is important that you check for extraneous roots. Or remember, another word for root is solution, and extraneous basically means several things. You could think of it as adding a solution that's not a solution to the original equation, or you can think of this as being a false solution. Okay, so it's just an extra solution that you end up with, but it's not a solution to the original. Okay, all right, so let's look at an example. So we're going to solve each of the following equations. So solve each equation. All right, and so here's number one. So number one, we have the square root of 9x plus 55 equals x plus 5. Okay, so notice that in this radical equation, the square root equation, you have variables on both sides. You see that? There are variables on both sides. It would be such an easier problem if that variable x was in there and all you had was this. And so you would square both sides and it would lead to a linear equation, all right, from a previous lesson. But the fact that there's an x on both sides, there's a variable on both sides, is going to make it a little bit more complicated for you. It's still doable. You can do this. All of you can solve this equation. It's just a little bit more steps that you have to deal with. Okay, so remember, when solving a radical equation, a square root equation, you have to get the square root by itself, and it is. Okay, so it's step one. So step one is to get that square root by itself. Step two is, once you get it by itself, you want to get rid of that square root symbol. You want to get rid of that radical symbol. In this case, it's a square root. So you're going to raise both sides. I'm going to write it over. You're going to raise both sides to a power equal to the index. So that way they undo each other. So remember, square root, so you're going to square both sides. And so when you square both sides, the square root function and the squaring function are inverses of each other. They undo each other. So you're left with the radicand. And so, and it kind of makes sense because the square root of 9x plus 55 times the square root of 9x plus 55 is 9x plus 55, right? You learned that in a previous lesson. So remember, the square root of 9x plus 55 times the square root of 9x plus 55, because that's what you're doing here when you square it, is the square root of 9x plus 55 squared, right? And then the 2 is divided, the exponent is divisible by 2. 2 divided by 2 is 1. So that's just 9x plus 55. It kind of makes sense because 9x plus 55 times itself is 9x plus 55 squared. So that's something you learned in a previous lesson. But many students just think of this as the square root and the square function undo each other. And so you're left with the radicand. Okay, so then we get this. So then we get 9x plus 55 equal, and then I have to square the binomial. So remember, you have enough experience from a previous course and from even this course to go ahead and square a binomial. But if you have to write it out, you write it out. So you can say x plus 5 times x plus 5, right? And then you're going to FOIL. X times x is x squared. The outer is 5x. Now, since those binomials are the same, the outer and the inner should be the same. So plus another 5x. And then the last, 5 times 5 is 25. And then combine like terms, you get x squared. 5x and 5x is 10x plus 25. So that is this. So x squared plus 10x plus 25. Okay? And now notice I went from a radical equation, a square root equation, to a quadratic equation. Now remember, the only experience that you have in this course in terms of solving a quadratic equation is by factoring. And so when factoring, you got to bring all the terms to one side, have a 0 on the other side, and then remember that's where you use the zero factor property. So that was one of the first, that was something you learned probably in the first 2 weeks of, or the first 3 weeks of the semester. Okay, so let's go ahead and subtract 9x from both sides. And so when I do that, 9x minus 9x is 0, so I get 0 plus 55 is 55, right? Equal. And then x squared, 10x minus 9x is a positive x plus 25. And I'm going to subtract 55 from both sides. And so 55 minus 55 is 0, so 0 equals x squared plus x. And then 25 minus 55, and again, if you have to use your calculator so you don't get that wrong. So you're going to get 30, right? But it's going to be a minus 30. Now I'm going to go ahead and transpose this because many students prefer to have 0 on the right-hand side. So 0 equals x squared plus x minus 30 is the same as x squared plus x minus 30 equals 0. You just transpose the sides. Okay, and then you factor. So you factor this, and you should get xx. Let's see, negative 30. That, and you want the middle term to be a positive x. And so what's going to work will be a positive 6 and a negative 5. Always double check. Remember, the outer is a negative 5x. The inner is a positive 6x. When you add up, you get a positive x. Positive 6 times negative 5 is negative 30. And now you set each factor equal to 0, just like this. And so you have two linear equations now, so you get x to be negative 6 and x to be 5. Okay? All right, now be careful. You remember, you have to check for extraneous solutions because you raise both sides to an even power. 2 is an even number. So if you square both sides, or you raise both sides to the 4th power, or you raise both sides to the 6th power, you have to check for extraneous roots. And so we have to check for extraneous roots. So let's go ahead and check. So we're going to check right here. So we're going to check x equal negative 6 first. So always go back to the original. Always go back to the original. All right, so the original being this right here. So check x equal negative 6 in the original. We'll write the original over. 9x plus 55 equal x plus 5, right? Okay, and so let's go ahead and plug wherever C and F, I'm going to substitute negative 6. I get the square root of 9 times negative 6 plus 55. And I want to see if that's going to equal negative 6 plus 5. Well, 9 times negative 6 is a negative 54. And a negative 54 plus 55, if we stick with this right now, that negative 54 plus 55 is a positive 1. So I get the square root of positive 1, and that's just 1. Now be careful. Negative 6 plus 5 here is a negative 1. And so the question is, are those equal? The answer is no, not equal, right? So what that means is that negative 6 is not a solution to the original problem. Now, it's a solution to this quadratic, because if you substitute negative 6 is a solution to this equation, because negative 6 times itself is 36. 36 and a negative 30 is a positive 6, and a 6 and a negative 6 is 0. Okay, so it's a solution to this. So that's why they call it an extraneous solution. It's a solution to this, but not the original. So when you square both sides, you introduce an extra solution to the process, but it's not a solution to this original equation. So this right here is an extraneous solution. So that's not a solution. Extraneous root. Now we got to check 5. So now let's check x equal 5. So when I check x equal 5, again, you go back to the original, go write the original over. So I get 9x plus 55 equal x plus 5. All right, now remember, I will be looking to see if you're checking for extraneous roots. All right, so I need to see some work. Don't just all of a sudden write the word extraneous. I don't see how you determine that. Okay, so it's important. It's important that I see what you're doing. Okay. All right. And so you're going to substitute 5. So get the square root of 9 times 5 plus 55 equal 5 plus 5, right? And so 9 times 5 is 45. And so I get 45 plus 55. 45 plus 55 is 100, and so the square root of 100, and this is 10, so those are equal to each other. Square root of 100 is 10, and this is 10. So 5 is a solution. So this right here, in terms of your answer, for your answer, you're going to say the solution. You're going to say x equals 5. That's the only thing you're going to write. Okay? So even though you ended up with two proposed solutions, since I raised both sides to even power, I had to check. And it turns out that -6 does not satisfy the original equation. It satisfies the quadratic one, but not the original. And so that's an extraneous solution, an extraneous root. So that's not a solution. And so when I check 5, 5 does work, so 5 is the only solution. Okay? All right, so that's number 1. All right, so let's do another one. So let's look at number 2. All right, number 2, let's suppose we had this. Number 2, we had, I gotta move it over. All right, so number 2, we have x equal the square root of 2x minus 10 plus 5. All right, so x equal the square root of 2x minus 10 plus 5. Okay, and so remember one thing, that before you raise both sides to a power, to get rid of that radical, you have to get the radical by itself. It's not by itself. See, they have that plus 5 here, that extra term. So we got to subtract 5 from both sides. So the first thing you're going to do, so your work's going to be this. So I'm going to go ahead and rewrite this over. So here's your work. You're going to say subtract 5 from both sides. And so you're going to say x minus 5 equal the square root of 2x minus 10. Okay? And now I have the radical by itself. So now I'm going to square both sides. I'm going to rewrite this over. And so I'm going to square both sides. Remember, you raise both sides to get rid of that radical. You're going to raise both sides to a power that's equal to that index. So you're going to square both sides. And so when I go ahead and square this, so x minus 5 times itself, I'm going to get x squared. The outer is a negative 5x, the inner is a negative 5x, and the last is a negative 5 times negative 5 is a positive 25. And so I get x squared. Negative 5x and negative 5x is negative 10x plus 25. So that's this side right here. So I get x squared minus 10x plus 25 equal. And remember, these undo each other. The square and the square root undo each other. So you're left with 2x minus 10 on this side. All right, so notice I went from a square root equation to a quadratic. And so the only way you know how to solve a quadratic in this course is to use factoring. So we got to bring everything to one side, all the terms to one side. So in order to use the zero factor property, I have to have 0 on this side. So I'm going to subtract 2x from both sides. And so I have, that's a minus 10 right here, by the way. So I have x squared, a negative 10x and a negative 2x is a negative 12x. Plus 25 equal, this is 0, a negative 10. Then adding 10 to both sides, I get x squared minus 12x plus 35 equal 0. Okay? All right, now factoring the quadratic equation, so factoring the trinomial here, let's see what we get. We get x, that last sign's positive, so they're going to be the same sign, they're both be negative. And it's going to be 7, what, 5? 7, 5? Okay? And so we said each fact equal to 0 using zero factor property. So I'm going to get x equal to 7 and x equal to 5. All right, so those are my proposed solutions. Now, since I raised both sides to even power, both may not work. One may work, the other one may would. You got to check. You got to check for extraneous roots, extraneous solutions. So let's do the work for checking. So let's go ahead and check x equals 7. You must always go back to the original, So I'm going to write the original over. So here's the original, x equal the square root of 2x minus 10 plus 5. Okay? All right, so let's check 7. So wherever we see the variable x, I'm substitute 7. So I get 7, and we see that's going to equal the square root of 2 times x. X is 7, minus 10, and whatever that is, I'm going to add 5 to it. And so I get 7. I want to see that's going to equal. Now, when I simplify the radical, 2 times 7 is 14. So I get the square root of 14 minus 10, right? Plus 5. Well, 14 minus 10 is 4. So I get the square root of 4 plus 5. Now the square root of 4 is 2. So is 2 plus 5 equal to a 7? The answer is yes. Okay, so x equals 7 is a solution. So that's going to be a solution. Okay, now let's check 5. So we're checking x equals 5. All right, so you must check for extraneous roots. So when I check x equals 5, go back to the original. So I'm writing the original equation over. All right, and wherever I see the variable x, I'll substitute 5. So is 5 equal to, and here I get 2 times 5 minus 10 plus 5. Well, 2 times 5 is 10. 10 minus 10 is 0, right? So the question becomes, is 5 equal to the square root of 0 plus 5? Well, the square root of 0 is 0. And 0 plus 5 is equal to 5. So that's a solution also. So I want you to notice is that you didn't end up with any extraneous roots. There aren't any. So both of those are your solutions. So your answer, you're going to say, so in the blank, you're going to say solution. And it will say solutions with parentheses around s because there may be just one. One, remember, you when we do these, one could be an extraneous root, so you just have one solution. But in this case, it's both of them. So you're going to say x equal, here's how I'm going to write it though, 7 comma 5 in the blank. All right. Don't put that in parentheses. You put that in parentheses, that looks like you're saying it's a point. And 7 is not an x coordinate, and y is not a y coordinate. Okay. So 7 is a solution to this equation, and 5 is a solution to this equation. So leave it like that. All right, that's number 2. Okay, let's do number 3. So suppose in number 3, we had this. So this was number 3. Let me remind myself what number 2 was. All right, that was number 2. So let's make this number 3. All right, suppose we have this. We have the square root of 36, oops, sorry, wrong one. Let me do this over. Okay, so this is going to be number 3. So here's number 3. Number 3, you have the square root of 5x squared plus 20x plus 36, that's all the radicand, and that's equals 6. All right. Now remember, you have before you raise both sides to a power, the radical has to be by itself, and notice that it is already. So this is already by itself. So number 2, if you recall, number 2, it was not. So I had to do some work to get it by itself. Once I got the radical by itself, then I raised both sides to the index power. Here it already is. So my first step, when I'm going to go ahead and rewrite this over, my first step is going to be to raise both sides to the second power. So I'm going to square both sides because the index is 2, right? Square root 2, just like this. And so the square and the square root undo each other. So you get 5x squared plus 20x plus 36 equal, and then 6 times 6 is 36. Okay. Now, so I went from a square root equation, a radical equation, to a quadratic. So I'm going to bring the 36 to the other side because I want this to be a 0 so I can factor. So I get 5x squared plus 20x plus 36 minus 36 equals 0. And notice that this 36 and negative 36 is 0. So you're left with 5x squared plus 20x equals 0. Okay? All right, now, so let's factor this. You got to remember how to factor this. All right, so notice the first thing you should do is notice that you have 2 terms here, 2 terms. So don't do those 2 binomials because that's not a trinomial right here. And then it's not a difference of 2 squares or anything like that. But you can factor out a 5x. That's the first thing you should do. So when I factor out a 5x, the GCF is 5x. So I get 5x times x plus 4 equals 0. And so I'm going to say each fact equals 0. I'm going to think of this as one factor, even though there are 2 factors. 5 is a factor, x is a factor. I'm going to put this as 1. So I get 5x equals 0 and x plus 4 equals 0. And then when I solve for x, one of my proposed solutions is 0. I don't know if it's a solution yet. I got to check. 0 divided by 5 is 0, right? Over here, I get x to be negative 4. So both may work, both may not. One may work. All right, so remember, whenever you raise both sides to even power, one of these or both of these may be extraneous roots. So you got to check the original equation. All right, so let's check 0 first. So let's check. So you're checking for extraneous roots. Check x equals 0. So go back to the original equation, which is this. Okay, and wherever I see the variable, I'm going to substitute 0. So I get the square root of 5 times 0 squared plus 20 times 0 plus 36. And I want to see if that's going to equal 6. Well, 0 squared times 5 is 0. 20 times 0 is 0. So all you're left with is 36. 0 plus 0 plus 36 is 36. And here's what I'm asking you. Is the square root of 36 equal to 6? And the answer is yes, because the square root of 36 is 6. So x equals 0 is a solution. So that's going to be a solution. So I know right away we have at least one solution, that's 0. Now let's check -4. So I'm going to check x equal -4. So when I check x equal -4, again, you go back to the original. I'm going to rewrite this over. So I get 5x squared plus 20x plus 36 equal 6. So wherever I see the variable x, I'm going to substitute -4. Now, since I'm substituting a negative number, you see how when I put that 0, I did not put parentheses there? I'm going to need it here because I'm raising a negative number to an even power, so I need to be careful. So I'm going to say 5 times the -4 squared, just like this, plus 20 times the -4, okay? And then plus 36, and I want to see if that's going to equal 6. All right, well, -4 squared is 16, right? And then 16 times 5 will give us 80. So this is 80 right here. So I get the square root of 80. A -20 times a -4 is a -80 plus 36. And I want to see if that's going to equal 6, right? Well, 80 minus 80 is 0. 0 plus 36 is 36. I get a square root of 36. And notice that that is true. All right. So this is a solution as well. And so therefore, you're going to say your answer for your answer. You're going to say solution. Both of them work. So you're going to say solution x equal 0, -4. 0, -4. Let me kind of do this over. 0, -4. Again, don't put that in parentheses. You put in parentheses, you're indicating that's a point. And that's not a point. Those are solutions to the equation. Those are x values. So you put a circle, you put parentheses, you're indicating that's an x, that's a y, okay? You know that's not y because you're saying x equals 0, x equals -4. All right, let's do one more. All right, and that's all it is. So notice that in every square root equation, I ended up with a quadratic in every case, okay? And always remember, when you raise both sides to the even power, you have to check for extraneous solutions, for extraneous roots. So that's something you got to remember about square roots. And the more you do, the easier it is to remember. Okay, so this is going to be number 4. All right, number 4. So let's say this is number 4. So let's say we have y equal a -1 plus the square root of 5y minus 1. That's a y right here. Okay. All right. So remember, I have this square root equation, I have this radical equation, and to solve a radical equation, you're always going to raise both sides to a power equal to the index. But to do that, you got to make sure that the radical is by itself, and it's not because you have that -1 term here. So we're going to go ahead. So the work's going to be, the first thing we're going to do is add 1 to both sides. So we go ahead and rewrite this over. And okay, so we write this over. Okay, and so we're going to get add 1 to both sides. So I get y plus 1 equal, this is 0, and I get the square root of 5y minus 1, right? And now I'm going to square both sides. So I'm going to square both sides. I get 5y plus 1 times itself. So when I FOIL that out, when I say 5 plus 1 times itself, remember, you're going to get y squared. The outer and the inner added together, that's 1y, that's another 1y, so that's 2y. And then 1 times 1 is 1. So that's going to be this. So y squared plus 2y plus 1 equal, and then the square and the square root undo each other, so you get 5y minus 1. Okay, so notice I have this quadratic equation. So let's go ahead now and subtract, so bring all the terms to one side so I can use a zero factor property. So I'm going to subtract 5y, just like this, and so I get y squared. 2y and a negative 5y is a negative 3y, plus 1 equals, this is 0, a negative 1. Adding 1 to both sides, I get y squared minus 3y. 1 plus 1 is 2, equals 0. Okay, so I have this quadratic equation, have 0 on the other side, so let's factor. And so when I factor, I get y minus 2, y minus 1. And so notice the outer and inner, a negative y and a negative 2y gives me a negative 3y. Setting each factor equal to 0, I'm going to get the solution y equal 2, y equal 1. Okay? But remember, you raise both sides to even power right here. So you have to check for extraneous roots. So let's go ahead and check y equal 2. You go back to the original problem, and so here's the original. The original was this right here. Okay? So let me go ahead and rewrite it. So you have y equal negative 1 plus the square root of 5y minus 1. Okay, so wherever we see the variable y, you're going to substitute 2. So I get 2. I want to see that's going to equal negative 1 plus the square root of 5 times 2 minus 1. Okay? All right, let's simplify this radical, in particular the radicand. 5 times 2 is 10. 10 minus 1 is 9. So 2, I want to see that's going to equal negative 1 plus the square root of 9. Well, the square root of 9 is 3. So 2, I want to see that's going to equal negative 1 plus 3. And remember, negative 1 plus 3 is 2, so that's true. All right, so that will be a solution. So that is a solution to the original. Okay, let's check y equal 1 now. So let's check y equal 1. So go back to the original, and where we see the variable y, you're going to substitute 1. So 1, I want to see that's going to equal negative 1 plus the square root of 5 times 1 minus 1. So where we see how the variable y, substitute 1. Well, 5 times 1 is 5. 5 minus 1 is 4, right? So that becomes, so you want to see 1 is going to equal negative 1 plus the square root of 4. Well, the square root of 4 is 2. So is negative 1 plus 2 equal to a 1? Yes. So that's the solution also. So there were no extraneous roots here. So both of those are going to be solutions to the original problem, original equation. So your solution, you're going to say in your blank, you're going to say y equal 2, 1. All right. Okay, let's look at 5. All right, so 5. So see, it's not that bad. It's the same process every time, right? You raise both sides to an even power. And this even power 2 here because you're dealing with square root equations, but you have to check for extraneous roots at the end. All right, so number 5. Let's say we had this for number 5. We had 1 equals, oops, sorry, wrong one. All right, so let's say we had this for number 5, excuse me. So let's say we had the square root of 2x plus 15 minus x equals 6. So the square root of 2x plus 15 minus x equal 6. Okay? All right, so again, remember you got to get the radical by itself, so I got to get rid of this term. So I'm going to add x to both sides. So let's do the work. So I'm going to rewrite this over. Okay, so I'm going to add x to both sides. So I get the square root of 2x plus 15 equal, this is 0. And then I get x plus 6, right? X plus 6. Let me make sure I didn't do that one already. Okay, I'm good. All right. So now, since I have the radical by itself, I'm going to now need to get rid of that radical symbol. So the index is 2. Here's the idea of square root. So get rid of the square root. You're going to raise both sides to the exponent 2, to a power 2. The square and the square root undo each other. So you get the radicand, 2x plus 15, equal. When I FOIL this, remember that means x plus 6 times itself. When I FOIL this, I'm going to get x squared. The outer 6x, and so is the inner, because the binomials are the same. So you get 12x, and then 6 times 6 is 36. So that's going to go here. So x squared plus 12x plus 36. Okay, so this is quadratic now, so I'm going to bring all the terms to one side. So let's do one at a time, though. So I'm going to subtract 2x from both sides. And so 2x minus 2x is 0, so I get 15 equal x squared. 12x minus 2x is 10x plus 36. Subtracting 15 from both sides, I get 15 minus 15 is 0 equal x squared plus 10x. And then 36 minus 15 looks like, what's that, a 21, positive 21? Okay, and let's go ahead and factor this now. So I get 0 equal, when I factor this, I get x plus 7 times x plus 3. And I'm going to set each factor equal to 0. So I'm going to get x plus 7 equals 0, x plus 3 equals 0. So I get x to be a negative 7 and x to be a negative 3. Okay? Now be careful. Those are solutions to this quadratic that you just did. That's a true statement. That is a solution. Both of those are solutions to the quadratic, but the problem was not quadratic. The problem was a radical equation. So you raise both sides to an even power. When you do that, it is possible you could have introduced extra solutions to this process, but those may not be solutions to the original. So hence the idea that extraneous solution. So you got to check. All right, so let's do the first one, x equals 7. Let's see what happens there. Negative 7, rather. So I'm going to go ahead and rewrite the original. So here's the original equation. Always go back to the original. Okay, and so let's see what we get. All right, so I get the square root of 2 times negative 7 plus 15 minus a negative 7, and I want to see if that's going to equal 6. Okay, so you're subtracting a negative 7. Well, 2 times a negative 7 is a negative 14, right? So I get negative 14 for plus 15. I'm subtracting a negative 7, which means adding a 7. Okay. Negative 14 plus 15 is 1, so this becomes the square root of 1 plus 7, and I want to see if that's going to equal 6. Well, square root of 1 is 1, so is 1 plus 7 equal to 6? The answer is no, because 1 plus 7 is 8, right? So that's not a solution. So not a solution. So it was no. So that's not true. Not true. So that means that this is not a solution. All right, so not a solution. Okay, which means that was a solution that was introduced because of that squaring process. All right, so this is extraneous. Okay, now let's look at this one. So let's check x equal negative 3. So you go back to the original. So my original was 2x plus 15 minus x equals 6. So where I see the variable x, I'm going to substitute negative 3. So I get the square root of 2 times negative 3 plus 15, subtract a negative 3, and I want to see if that's going to equal 6. Well, 2 times a negative 3 is a negative 6, right? So I get the square root of negative 6 plus 15. Subtract a negative 3 means add 3, and I want to see if that's going to equal 6. Well, negative 6 plus 15 is 9. So that becomes the square root of 9 plus 3, right? Well, the square root of 9 is 3, and is 3 plus 3 equal to a 6? Yep, sure is. So that's a solution. So the only solution is this, right? This is extraneous. That's not a solution to the original equation. It's a solution to this quadratic. It's a solution to this linear equation here, but it's not a solution to the original. So in the answer, you're going to say solutions. And there's only one. You're going to say x equal negative 3. Okay? All right, so that was the lesson on solving radical equations, square root equations that lead to quadratic. So notice every one of these problems led to a quadratic. And even with the previous lesson, whenever you raise both sides to even power, you have to check for extraneous roots. Okay, so that's going to take care of this lesson.